Can population-based engagement improve personalization? This work introduces a novel dataset and experimental results answering this question. This work revolves around BLE dataset, a novel dataset for predicting population-based engagement in video lectures. Population-based engagement is the general engageability of a video across an entire user population. As main contributions from this work, we construct a new dataset with about 12,000 unique video lectures and watch time based engagement signals coming from over 1.1 million unique learners. We establish two formal prediction tasks and also report experimental results addressing additional research questions we have identified. First, let us see how the VLE dataset is created. The data for VLE dataset comes from videolectures.net website, a popular open educational resource video repository that keeps scientific videos and research talks. We take the videos and first we transcribe these videos using translectures. We also take the metadata of the videos and using the transcripts and the metadata, we construct content-based and video-specific features that we use in our prediction tasks. Additionally, we take the transcriptions and we use entity linking to associate Wikipedia topics into the transcription, and we also use these topics as part of our feature set for the VLE dataset. When it comes to the labels, we extract the interaction logs from videolectures.net and process these logs to harvest both explicit and implicit labels, and we associate these labels with video lectures to construct the VLE dataset that is presented in this work. The proposed VLE dataset is an extension of the VLE small dataset that we have published in Educational Data Mining Conference in the past. As you can see from the table, the new proposed dataset is a larger and more recent version of the VLE small dataset. Additionally, there are a few differences. The new VLE dataset is restricted to English lectures. In terms of labels, it contains the full set of engagement labels that are associated with individual video lectures in order to represent the distribution of engagement values more precisely. In terms of features, additional Wikipedia topic-based features have been added to the dataset. As the second contribution of this work, we identified 5 research questions that demonstrate the usefulness of the constructed VLE dataset. We have used a random forest regressor model, as we used in our previous work, to train the context-agnostic population-based engagement prediction model, and to demonstrate its usefulness with cold start problem in personalization models, we used another proposed personalization model called TrueLearn Novel. Do population-based engagement prediction models trained on the VLE dataset improve predictive performance on this task? This is the first research question we wanted to answer. In order to answer this, we established 2 formal tasks. An engagement prediction task, which is evaluated based on root mean square error, and engagement-based video lecture ranking task, which is evaluated based on Spearman rank order correlation coefficient. As you can see from the results, the new VLE dataset, which leads to a new model, significantly outperforms the context-agnostic model trained on the VLE small dataset. The next 2 research questions we wanted to answer is how the training data size impacts the performance of the model and how relevant is this data set for computer science lectures, given that videolectures.net abundantly contains computer science related materials. When it comes to the impact of the training data size, we can observe from the second plot in this figure that the ranking performance saturates after utilizing 60% of the training data. This means that the ranking problem becomes significantly harder after hitting 60% of the data. However, we can see that the root mean square error continues to decrease with more data. The orange line in the plots, which represents performance on computer science related lectures, gives good evidence that models trained on this dataset is suitable for modeling videos related to computer science. The next research question we looked at is VLE datasets' relevance to MOOCs and e-learning related use cases. From the dataset, we identified a set of lectures that represent or resemble the style of teaching in MOOCs and e-learning. When we trained the model on the rest of the lectures and tested the performance on this selected dataset, we observed that the model is capable of ranking and predicting engagement on these e-learning related videos impressively. Finally, we designed an experiment to investigate how a context-agnostic model trained on the VLE dataset could be used to address the cold start problem in personalization. In order to do this, we used the TrueLearn novel model that has been proposed by our group earlier. This is a personalization model that is inspired by the item response theory. It starts with a non-informative prior about the skills of the user and over time learns a skill parameter that is used to predict engagement. One of the observations in this model is that it has no information about the user nor the lectures in the first timestamp to make the predictions. Therefore, what we did was to use the context-agnostic model that we trained on the VLE dataset to predict the engagement of the user in the first timestamp. As the results indicate in the table, the integration of the context-agnostic model trained on the VLE dataset led to a significant improvement of accuracy and precision. Through this work, we propose VLE dataset, a new dataset that can be used to model population-based engagement of users with video lectures. Then we formulated research questions that we answered through various experiments to prove the usability of this dataset. Through our experiments, we showed that the newly proposed VLE dataset significantly improves the predictive performance of population-based engagement prediction. We also found out that increasing of training data has a positive impact on the performance of the prediction tasks. Then we also did further experiments to demonstrate the relevance of this dataset to build models to work with computer science related videos and also work with MOOC and e-learning related scenarios. Finally, our experiments around integrating this model with personalization models showed that population-based models can improve personalization of educational videos. Thank you for listening to our presentation. If you want to access the dataset and the code which is publicly available, please refer to the link in the slide. If you want further information about this work, please do not hesitate to contact me using the email address provided in this presentation. Thank you very much.